Okay, with this video I'd like to help you understand what is the moonlight, and that in fact the moon, the sun, the stars are in fact lights. The moon itself is at a height of 32.234 miles high. That's just over 170,000 feet. Now let me explain to you, at that altitude, that height above the flat plane of Earth, what you call earthy dirt, you run into a different atmosphere and concentration of gases. You run into what are called lighter than air gases, and one in particular, neon. Neon allows, as you know, things to glow. Right? So this is just pictures of the moon light coming into view, and as you can tell, it's quite bright. And what I'm going to do is with the next few photos and just blend them in while I tell you some things, is just take a long exposure shot, which is just allowing as much light into the camera as it can take, and then that's going to highlight the sky for you and show you that in fact the illusion, the blue illusion, can also then be created at night, depending on how long you want to leave your shutter open. Okay. So then, with that in mind, you have this idea of the moonlight, and you can see this. If you notice these images, you're going to see a splashing on the side of colors, red and blue, making a purplish. All right, it's going to be off to the side, and what that is that's going to be the source of this projection. Now, each one of these, the sun included, has a source of projection. This one in particular is I've taken a photograph of it. I'm going to show you that as soon as I explain a little bit more of the mechanics of this to you. So then you have a plane, and planes are nothing more than atmosphere changes precisely, allowing and disallowing combustion, let's say at 172,000 feet, where then the O2 is at 0. So then combustion is just out the window. So then you look at this idea, and you have to understand, why is then this thing being projected sometimes to where it looks like you can see clouds behind it? And that is because you're seeing clouds behind it that are farther down the plane. For example, if you see this rising in the state of Arizona, which is just on a map, a close distance to the state of California, where I am in particular, someone will see this rise at this level in Arizona and not see it yet in California. It will not be visible in the sky. That then proves to you that this is a lot closer to the ground than you've been told. And it's also a projected light. As you can see here, look to the right side, you see that almost trumpet piece or flute opening. That is then from the projector, all right? And then that is at a higher plane projecting that, what you see as the so-called moon, all right? Now what I want to do is just go ahead and blend in a few shots and show you this at night, and show you that you can then highlight clouds, brighten it up, allow more light in, and see more of the nighttime canopy, what I call it, the action behind the action. If you were to zoom into these photos, what's projecting that then to you is this. This is called Satellite Dave J, being that nobody else wanted to own it. Nobody else even wants to tell me that they see it. All right, and there is one person who has a video up that has helped out and has shown people that this is in fact real. All right, you can see it, and as long as you know what you're looking at, and I'm trying to show you here what you're looking at, you will then see this image, which is what you see as the moon, and you will see the projector off to, if it's going to be, if you're in the United States, let's say, it'll be to your right and below. If you're down, if you're farther below what's called the equator, and I'll get to that in a minute, you will see it on your other side, your left. Okay. So then, if you then now know that, what I'm going to do is then tell you exactly what's going on here. This is a projection into space, and space being atmosphere above your head. All right. And now, why do you see it in a different orientation if you were in, let's say, Australia or something that's said to be below the equator. Well, that is because the projection is at the level of the equator. All right, does that make sense? Just at the higher plane, just at 32.234 miles higher. All right, and then it rotates on its course. All right, so then at that equator, you're going to see what's called, with a projection image, you're going to see a rotation change, because it's going to be, think of the figure 8. All right, and then noticing that on these, every time you look at the so-called moon, you can only look at the one side with the so-called mountains. On the left side here in particular, looking from the so-called north, that you can zoom in on. The so-called the right side, you can never get a clear picture of, because it's just a static image. There's nothing there to focus on. Then when you go through what's called the equator, you'll have just a morphing, and then the next thing